are here with another chapter for chemistry this time, for class 7, and the name of the chapter is Physical and Chemical Changes. These are the changes that we have noticed every day. So how do you differentiate between physical change and a chemical change? Let's go into the details. So here are the definitions for physical changes and the chemical changes. Let's just go through the definition. Definition for physical changes is a change in which no new substance is formed is called physical change. A physical change is a temporary change and is reversible. In a physical change, the composition of the substance remains unchanged. So what it means is, in a physical change, just the physical attribute of things change. The way it looks, the way it feels. Those are the only things that changes. Okay, but what the product or the object is made up of, that thing doesn't change. Another thing that you need to remember is physical change is temporary, okay, and is reversible. Okay, we'll get into detail about each and every point out here in the next slides. So we move on to chemical changes. A chemical change is a permanent change in which an entirely new substance is formed with different properties. It is a permanent change and irreversible change in which the original substance loses its own composition and properties. So in chemical change, what happens is a substance goes through a transformation, okay, a change, and it is a permanent change. It cannot be reversed back. It does not change back to what it was before. And the whole property of it changes. In physical change, the properties don't change. Okay? But in chemical change, the properties change. Like for example, if I were to give you an example of physical change, would be a tree being cut down and being turned into chair. Even if you cut the tree, the wood remains the wood. Yes, the shape of it changes, but wood is still the same. But in chemical change, we talked about in previous classes, example of a chemical change would be formation of water. You have hydrogen gas, you have oxygen gas, and both of them come together and they form a liquid, which is water. Water has totally different properties compared to the gas, which is the oxygen and the hydrogen, right? So that is a chemical change. Now let's talk about physical changes, okay? Like we discussed, physical changes are limited to changes that result in a difference in display without changing the composition. Some common changes, but not limited to, are the change in texture, change in color, change in temperature, shape, and change of state. This is the part that we need to focus on. The rest we have seen, right? For example, when a fruit rots or when a fruit ripens, the fruit doesn't change. The taste of the fruit changes slightly. Some become sweeter, some become sour. So taste changes, but the chemical composition of the fruit stays the same. The fruit is the same. It's just the color has changed. Okay? Only the physical properties change. So we know about all these things. But what do we understand about change of state? Now let's take the example of water again. When you change the temperature of water, when you freeze it, it turns into ice, turns into solid, right? Physically, it becomes solid, which is different from liquid, which was water. But the composition is still the same. It's still H2O, right? It's still 2 part hydrogen and 1 part oxygen. It's just that the shape has changed into solid. Similarly, when the water is heated up and when it's boiled, the water turns into water vapor, right? Water vapor again is H2O, but it is in gaseous state. Okay, so that is what change of state means. Physical properties include many other aspects of a substance. The following are, but not limited to, physical properties, right? So we talked about how in a physical change, only the physical properties change. And what are those physical properties? Here they are. Luster. Okay, luster means does one's ability to shine. Malleability is one's ability to be beaten up or hammered into thin sheets. Ability to be drawn into a thin wire. Okay, density of substance, viscosity of substance, solubility of substance, mass, volume, etc. So these are the physical properties. A change in any of these would mean it is going through a physical change. Okay, any change in these physical properties is referred to as a physical change. We have already discussed. For further information, please go through the matter, the chapter matter, and the video that we have already discussed about matter, which is already there in the website. Please go through it for better understanding of change of state of matter. Now let's look at the characteristics of physical change. A physical change is a temporary and easily reversible change. Okay, we have talked about that. No new substances are formed during a physical change. Okay, again, we take the example of the wood. When you cut the tree doesn't turn into something totally different. Yes, it looks different, but it's still the wood, right? Wood is same, right? So that is what this line says. No new substances are formed during the physical change. And the third one, heat may be given out or observed in a physical change. Maybe. There's a high chance that it may not happen, but in some cases it does. So that's it. And the point being is, when it comes to chemical changes, heat and light energy is always observed or released. And the last part, no alteration in mass takes place during physical change. What it means is, again we go back to the example of tree. Okay, so you cut down a tree and you turn it into a chair. So you might think that the weight of the chair and the weight of the tree is going to be totally different. The mass of the chair and the tree is going to be totally different, but no. So when you scrape up the tree, when you cut down the excess part, all of those are also accounted for. So when you bring all of them together, okay, the mass of the chair and the mass of the tree is going to be same. Okay, so you have to take everything. You don't throw anything about. Nothing disappears. Now let's move on to chemical changes. Okay, chemical changes are very different from physical changes. What happens in chemical changes? A chemical change occurs when the substance's composition is changed. What it means is the whole composition, what it is made of. Okay, what a substance is made of. If it changes, okay, like for example, when you burn a piece of paper, paper turns into ash and then smoke, right? So there are two different things. It's totally different from where it started. What it was, paper, a solid object, and when you burn it, it turns into gas, that's the smoke, and ash. So that is a chemical change. When bonds are broken and new ones are formed, a chemical change occurs. Okay. Again, what happens out here is, let's say there is a molecule of an oxygen, there is a molecule of hydrogen. Those bonds, they break. Okay, and oxygen and hydrogen, they make a different bond. Okay, and they make a molecule of H2O. That is water. A molecule of water is made. So that is one bond is broken to make another bond, and another substance is formed. That is a chemical change. So these are the indicators. Okay, so whenever there is a chemical change, these are the things that tells us that a chemical change has occurred. When you see a change in temperature, when the color is different, okay, and when you might get new smells, okay, and when there is something formed, gases or solid objects are formed, and new totally new subject new substance is formed, then there is a chemical change that has occurred. Now let's move on to characteristics of chemical change. Now, the first one is new substances entirely with new properties are formed during chemical change. Like we talked about water, gases, hydrogen and oxygen, they come together and they make water, which is totally different from where it started, right? So the second one, chemical change cannot be reversed to get the original substance. Okay, like for example, you cannot break water into hydrogen and oxygen gas. You need, physically it's not possible, right? You cannot hold the atoms of oxygen and hold the atoms of hydrogen and pull them apart and you have gases. Okay, it's not possible. So the change is permanent. Third point, chemical changes are accompanied with change in energy in the form of heat, light or sound. I've already talked about this in the characteristics of the physical change, so I'm going to repeat it again. So in chemical changes, what happens is heat energy, light energy or sound energy is either observed or released. Okay, like for example, in a tube light or in a bulb. Okay, there's a chemical change happening inside the bulb, and the energy that is being released out is heat energy and light energy. Mostly light energy that we can see, but if you touch the bulb, then you can see there is a change in the temperature too, and that is due to the release of heat. The last point, a change in weight occurs during a chemical change. Okay, so whenever there is a change in the weight of a substance, then you know that a chemical change has occurred. So let's move on to examples of physical and chemical change. I want you to pause the video right now and solve this and send me the answers. I've already solved the first two for you. Tearing of sheet of paper. When you tear the sheet of paper, what happens? Does it change? The paper changes into something else? No, it doesn't. It just becomes small. So that is a physical change. Charring of sugar. Charring of sugar means like you take sugar, you put it in a pan, you heat the pan and you burn it, and the sugar turns totally black. The content reduces, it turns into liquidy form. What is that? It is a chemical change. Now similarly, grinding of substances, melting of butter in a dish, boiling, evaporation and condensation, burning of paper, hammering of metals to form sheets, rubbing of hand sanitizers that I hope you guys are doing every day. Make sure that you use hand sanitizers frequently when you go out and wear a mask. Please stay safe and stay home and study. Next point, rusting of iron, leaves in the autumn, cooking of food, fermentation and digestion of food. Okay, write down whether each of these processes are, each of these changes are chemical change or physical change, and send me the answers. Now we move on to a very important aspect of this chapter, that is the differences between physical and chemical change. We've already discussed about all of these, so let's just quickly read through it. In physical changes, no new substance is formed, only physical properties are changed. But in chemical changes, new substances are formed with entirely different properties. These changes are temporary and can be reversed, but in chemical changes, the changes are permanent and it cannot be reversed. For physical changes, heat and light may not be given out or observed. Okay, it may be given, it may not be given, but in chemical change, heat or light, sometimes both are generally given out or observed. Okay. Usually there is no loss or gain of weight in physical changes, but in chemical change there is always a change in weight from the original substance. Now let's move on to a physical change that we see in a day-to-day life, that is liquids changing into gases. For example, water changing into water vapor. Okay, so let's look at evaporation. Evaporation occurs in many different kind of liquids. So what are the factors that affect evaporation? First thing is the nature of the liquid. Okay. Now, you must have noticed when you apply hand sanitizers on your hand, you see them evaporating quickly, right? But when you put water in your hand, it takes some time. So that proves that different liquids have different rate of evaporation. Second one is temperature. Okay, whenever there is a rise in temperature, there is always a rise in the effect of evaporation. Okay, a liquid evaporates rapidly if the temperature is increased. Second, surface area. Okay, this can be, you can understand this much more easier by imagining a scenario. Okay, take a glass of water, keep it on a table, take another glass of water and just spill it on a table. Which one do you think will evaporate faster? It's the water that has been spilled on the table. Why? Because it has got larger surface area that is coming in contact with the air. Okay, when it comes to glass, there is a smaller surface area which is coming in contact with the air, but on table there is larger surface area, right? So lastly, humidity. Okay, so how does humidity affect evaporation? It's very simple. If there is a high humidity, okay, then evaporation becomes slower. If the humidity is low, then evaporation becomes faster. Okay, and we can study about what is humidity and the effects of humidity in the later classes. Now, we've talked about physical changes and chemical changes. Let's look at factors which affect these changes. First thing is, for a substance to go through change, it has to come in contact with another substance. Okay, there has to be an interaction. Okay, that's the first point. Changes involve interaction. Okay. Second point is, there is always a change in energy. Okay, like for example, in physical change, there is a change of state and dissolution of substance in liquid, which means dissolving, how quickly or how a substance dissolves in liquid. Okay, and in chemical change, energy in the form of heat and light is always released or observed. We've already talked about that, and thank you for watching the video.